Okay, welcome to the next video in this series of lessons on electricity from the AQA Gcse Physics Specification course. Okay, so this one's on component characteristics. I'm going to be looking at three components. First one, really straightforward. It links nicely with Ohm's law, which I did in my last lesson. It is the resistor. So, if I was to have I as my y-axis and my V, potential difference, as my x-axis, and I have a positive bit of the current and a negative bit of the current readings, positive set of readings for voltage, a negative set of readings for voltage. What is this line telling me? Well, it's telling me current is proportional to voltage, so this is following Ohm's law, or it is ohmic. Okay? Ohmic is a nice word to use if you're describing something obeying Ohm's law. So, for your exam, you need to remember the shape of this graph. Okay? So nice and simple for that. The next one I want to do is a diode. So a diode, I draw my same set of axes, I, V, I'm going to have nothing for a huge chunk of my graph. Why is that important? Because what did we say? A diode can only let current pass one direction, and it doesn't let current flow in the opposite direction. So basically that's why we're getting no readings for current in this direction, and hence no current, no voltage. And there's a threshold point where we get lots and lots of current, or current beginning to start to enter through that diode, and hence we have some voltage accompanying it. Okay? So again, please remember that is the shape that a diode makes. Last one is a filament bulb or lamp. Okay? So it is simply like an S curve. Okay? It curves either side in the negative region and in the positive region. Why is that occurring? Well, there's a really thin wire, tungsten, made of tungsten in your traditional filament bulb. Okay, and when that gets really hot due to lots and lots of current passing through it, so the top end here and the bottom end here, that causes a lot of friction, so a lot of these electrons are hitting the lattice ions in the conductor and in the tungsten. Then obviously friction generates heat. Heat obviously needs to be passed on to the particles, and obviously the particles start to vibrate, and that means we get lots of vibrations of the particles, and as the electrons pass through, their pathway to the other side of the battery is a bit longer, because they've got to, battle or combat these vibrating lattice ions. So it's actually a less easier journey for them to make compared to when the current is lower, which means there's less vibrations due to less heat. Okay? So that explains this curve. Okay, but for your exams, please remember the shapes of these graphs. That's for foundation and higher tier exams. Okay, all the best.